Hi, I'm listening. Let's have a look at fitting a model for our bivariate data. So the key idea is we either want to use our residual graph or we can use the regular graph, and we want to look at the trend in particular, and we want to look at whether a linear or nonlinear model is better. Then we want to fit in the model and make the new scatter graph, and then we want to compare the fits. So here is a set of data about diamonds, and what I've got is on my x-axis I have my explanatory variable, and on my y-axis I have my response variable. So I've got my carat versus my price. Now one of the things I want to do first of all is I want to just add in a kind of a line hitting the top points, and then I'm going to hit another line that kind of goes along the bottom. And what this is doing is it's help drawing my eyes to what that pattern looks like. And I want to think about, does it look like there's a kind of a curve going on, or does that look like a straight line should fit through that data? So my first visual impression is that, you know what? Actually, maybe a curve might fit that one better, because it looks like it's kind of heading upwards in a curving fashion. So I started off just by doing a linear equation. So you can see here I have looked at I've got a linear model fitted, and I've come up with a gradient and so on. But when I look closer at this model, I would like to be able to see, and if I go back to this graph, what I'd like to be able to see is I'd like to be able to see a line that goes, the trend line that goes through the middle. So I'd kind of like it to be heading through the middle of the data. Okay, so that's kind of a rough guide. That's where I'd like to see my model estimating. So this one doesn't fit as well. So what I want to know is I want to know where does it not fit as well. And so I can look and say, for example, down the bottom here, you'll notice that trend line there, particularly in this part there, is the trend line is underneath the data. So in this particular section, so between about 0.2 and 0.3 carats, the model that has been fitted, the linear model, is underestimating the actual price. Equally, there are times when, for example, in this section here, where the trend line is a little bit higher than normal, okay? And at the end, we can see there at the end again, it's not necessarily estimating through the center of the data. The center of the data looks like it's starting to curve up more, where the model is not. So this is what I first want you to talk about, is I want you to critique the linear model that you have, and I want you to tell me about how well that model fits. Then we want to suggest what other models we could use. So here for example, I have gone and fitted an exponential model. And so that, if I just, sorry, let me do that. If I jump into here, then in my NZ grapher, so I started off with my linear model, and let me take this other one off. Then what I want to do is I want to change from that, and I might say, well, let me try some kind of exponential model. So there's my exponential model down the bottom. I could also try fitting a quadratic. I wonder if maybe a quadratic would fit reasonably well. I wonder if a linear model, oh no, that does not look like it's curving in the right direction. So there's a number of different models there that you can try. So if I jump back into here, so this is the exponential model, and I want to know how well does that fit. Well, it certainly fits better than it did before. If I draw my little lines above and below, like I did before, so if I add those kind of lines there, and another one down the bottom, kind of along there. Now compare that actual model that's been fitted. Well, it's definitely a much better fit than the previous one, and in particular, the area at the end. Okay, so this section here fits much better. That curve is actually heading upwards now, that trend curve. At the beginning, it's a much better fit than before, but now it's potentially overestimating a little at that initial stages. And through the middle there, it's kind of on the slightly lower side. So it's a better fit. Is it a fantastic fit? Possibly, possibly not. So here I have now tried fitting a quadratic, and I can tell that by looking up the top here. And so there's my caret squared. So that's my quadratic x squared. And so how well does this model fit? Well, if I look down at the bottom here, that certainly seems to fit better than the exponential one. The middle section again, that seems to be much more through the middle. And at the end there, that's not bad. It's not quite as good as I like, but there are these points up here that might be outliers, maybe, I don't know. But certainly that seems to be a little bit better fit, but I need to explain why it's a better fit. Another option I've tried here is fitting not an exponential model, but in this case it's a power model. So the general y equals a to the power of x, and in this case times another value b. So that's the kind of the general model, and it suggested a value of around 1.5. So how well does that fit? Well, again at the beginning there, better. Middle's not bad. Yep. And at the end, that's not bad either. So overall, there's a couple of options there that would be much better than the linear model that we first had. So that's what I want to be able to do. Now, the other thing that I want to do when I talk about the fit of the model, I'm just going right back to the original one here, is when I look at the scatter, okay, and let me find where's my little pointer gone? Let me choose a different color. Let's go with purple. If I look at the beginning here, look at how wide the variation is there. As the caret gets bigger, the variation, that line there, is getting wider. As I go further, as the carets increase, the variation is increasing further. Okay, so I know that for some values down the bottom, okay, so for small amounts of carets, so down this bottom end, the model fits better because there's a lower amount of variation, whereas at the top, there's a lot more variation. So because I've got this changing variation, that has an effect on how well my model fits as well. So there's a whole bunch of different things that we can talk about when we consider the fit of the model. The other thing that we can do, and let me escape out of that, jump back into my NZ grapher here. I could change this from a scatter graph to my residual graph. And what I'm looking for there, let me copy that over into here. What I'm looking for is when I draw my lovely little patterns on it. So again, I'm drawing the line kind of hitting the top points and a line hitting the bottom points. I can see that overall the trend, if I was to draw the trend through the middle there, that I would like, that's what it kind of, there's the middle and there's a curve. Okay, so this again shows me the same pattern as I saw on the original graph, just it's kind of amplified, and the spread and the scatter is amplified when I'm looking at a residual plot. So I'll get exactly the same ideas, but if I see a pattern in the residual, that means that I haven't got a great model. What I want to see on a residual graph, so if I had a residual graph with my line about 0, I just want to see all the data randomly scattered above and below with no pattern whatsoever. That means I've got a good model, as if I've got a residual graph just like that.